How the transformer impedance plays an important role for the short circuit studies. In this video, we will see this impact of transformer impedance on the short circuit current and also the impact of the grid short circuit current, the grid short circuit parameters. That means whenever we are going to change the grid short circuit current, maybe by more than 10 kiloampere or 20 kiloampere, what is the impact if there is a transformer? What is the impact in the transformer secondary side regarding the short circuit current? So this is a network where we have modeled this grid short circuit current as 20 kiloampere and x by r ratio is 14 considered, and I have considered 50 kilometer of transmission line. This is not important for this study case, but I have modeled this transmission line also, and this is the transformer. So here 110 MVA transformer is considered 420 by 11 kV transformer with percentage impedance of 12.5 percentage. Maybe I have taken the typical impedance here, 12.5 percentage, x by r ratio 45. These are the typical z and x by r values of this 110 MVA transformer. So now let's quickly jump to the short circuit study. So let's run this IC 60909. So what we can see, this short circuit current is 45.973. Let's check what is this. No, single line to ground. Okay, three phase. Yeah. So this is 43.219 kiloampere. 43.219 kiloampere short circuit current. We have created the fault here in this bus, transformer secondary side bus, and the short circuit current is 43.219 kiloampere. Okay, now let's change the short circuit current. Instead of 20, let's consider as 40 kiloampere. So 40. So we have not changed anything, this XYR ratios, only we have changed. Instead of 20, now it is 40. So now let's see what will happen. So previously, considering the grid short circuit current of 20 kiloampere, this transformer secondary side bus short circuit fault current is 43.219 kiloampere. So now let's run this, and now it is coming 44.41 kiloampere. So now almost only 1 kiloampere short circuit current is increased. With the increase of 20 kiloampere short circuit current in the grid level, only only 1 kiloampere short circuit current is increased here at the transformer secondary side. So if we have the transformer in between, then there will not be major impact in this transformer secondary side, or let's say this 11 kV side, there is a process plant, there is an industry. So in that case, if we have the transformer in between this grid and the process plant or the industry, if anything happens, means if there is a huge change in the short circuit current in the grid side, there will not be much impact here in the process plant or in the industry, right? Now let's again change the short circuit current. uh, Instead of 40, let's change as 60 kiloampere. Let's change another 20 kiloampere we are increasing. So considering 40 kiloampere, it is 44.4 kiloampere. Now let's run this once again. So it is now 44.821. So it is even less than 1 kiloampere. Whenever we are changing the grid short circuit current by 20 kiloampere here, instead of 40 we are considering now 60. Instead of 40 we are considering now 60. Now, the short circuit current at the transformer secondary side, this 11 kV bus, it is not increasing in that ratio. It is only less than 1 kiloampere. It is 44.82 kiloampere only. So that's what, if you have the transformer, then no need to worry about what is happening in towards the grid side. Maybe another network in future, they are going to add they are going to add multiple feeders also. They are going to add another transformers. Maybe in this grid side also, that the expansion in the utilities. So that time also, no need to worry too much about the upstream network, what is happening there, because you have the transformer to safeguard your plant, because there will not be much impact in this transformer secondary side short circuit current. So this was today's topic, and I hope it will be helpful whenever we are going to study this short circuit study using ETAP software or maybe any other simulation software. This concept is very much required, and this is the basic we should not forget during the power system study.